Lesson 5.1. We will represent linear functions using graphs, equations, and tables. This section is all about the multiple representation chart. We've done this several times in class. We have a verbal section, okay, which simply means that you're going to get some sort of statement. Okay, so the verbal scenario for the problem. Sally has 5 apples. She picks 2 more every day. Okay, that's our verbal statement. We also can represent that verbal statement through a table. Okay, so you could take and create a table with our x column and our y, our domain and range. X would be what? The number of apples or the days? Good, it would be the number of days. Y would be the total amount of apples that she has. Okay, that would be our output. All right, these two are the same. They just look different. This one's using words, this one's using numbers, but they would represent the same thing. Then we have another way we can represent that with an equation or an expression. Okay, right here. That's our fourth way. So we could take that verbal statement and we could turn it into an equation. Why don't you pause for a minute and see if you can figure out the equation for this? Good. Y equals 2x plus 5. That's the same thing as this. All we did was take these words and put it into numbers using numbers, variables, an operation, and an equal sign. Okay? Which we could take this equation and put it into the table. So far, these three are all the same. They just look different. That's all. The last thing is we could do a graph. Okay? We could take this verbal statement and graph it. We could take this table and graph it. We could take the equation and graph it. What would all three graphs look like? They would all look the same because they're the exact same thing. They're all representing this scenario. So here's an example of how we could graph it. Okay, we would have x as our number of weeks, y is our total apples, and we would end up with some linear equation. Okay, why is it linear? Because it forms a straight line. Very good. Okay, the big point is these are all four the same exact thing. They just look different. I mean, in your bedroom, have you ever rearranged your bedroom? If you have, it's still your bedroom, right? You didn't change rooms. You still walk through the same door to get to your bedroom. But maybe you put your bed over here and your desk over here. And then next time you switch it around. It's still your bedroom. It just looks different. That's the same thing with these. They're all the same. They just look different. So here's the same example, and I wanted to bring this back because we need to talk about the difference between equations and functions. So here's still the scenario, the domain and range, and we've graphed it. Is this a linear equation? Does this form a straight line? Yes. This is a linear equation. In just a moment, you'll also find this as something else, okay? But we have to define that first. So this is a linear equation. It has variables, it has numbers, it has an operation, and it has an equal sign. Okay, so that's the definition of a linear equation. Here's a more formal definition, so you can take a moment and pause this. And a linear equation has 2 variables, and each variable only appears once. X is not raised to any powers. Okay, so it's just simply like 3x, or 6x, or 5x. Again, look at these. They're all different. They all look different. Okay? But they're all equations. They all have a y equals. Okay? Or, as you've learned, we could do f of x using function notation. Got to bring that back. These could all be f of x equals the equation. Okay? Those are all the same. A linear function is a little bit different. So it's the same as a linear equation, except the big thing is x can be raised to a power. Okay, so here we have y equals x squared plus 3. Alright, the big thing is that this exponent right here. And it's going to make it look different. If you have a graphing calculator, I would recommend that you plug that in and see what it looks like. You should get something that looks like a U shape. That's called a parabola. It's still a linear function, because what we learned about functions is it has to pass the vertical line test. And if I draw a vertical line anywhere through here, it only hits one point. So that means it is a function, but it's not an equation because it's raised to this power, and it's not a straight line. Okay? You might want to replay that. So here's an example. Y equals x squared. Here's an example of that. Well, first of all, does it pass the vertical line test, making it a function? Can I draw a vertical line anywhere along here and it only hits one point? Yes. So we know that it's a linear function. But is it an equation? Look at your definition of equation. No, it's not an equation because this x is being raised to a power. Okay, it is simply only a linear function. Let's look at the next one. Okay, let me get my pen. Here we go. We have y equals 2x, linear equation or linear function. Does it pass the vertical line test? Yes, it does. It only hits one point, any vertical line that I draw. So we know it's a linear function, but is it a linear equation? Is x being raised to a power? No, it's not. It's both. And that's true. It can be both. So here, for your final test, this is what I want you to look at. All blank are blank, but not all blank are blank. So here's your word bank, linear equations and linear functions. Take a minute, pause this, and see if you can figure it out, because I'm going to put the answer in. All linear equations are linear functions. Okay? So things that are not raised to the power, they are linear functions, all of them. But not all linear functions, the ones that have y equals x squared, they're linear functions, but they're not equations. Take a moment, study that, give yourself a couple examples, and that's our lesson for today.